Cool. So yeah, we're going to talk about some folks' journeys from analytics to ML. Emily's not on this call, so I think it's safe to use data science if you want. I'll leave that up to y'all, but it's titled Analytics to Machine Learning to ML. For folks, if you want to keep the conversation going, kind of async or kind of via chat, we like to use Slack instead of Zoom for maybe obvious reasons. There's a Slack channel, Meetup Analytics. Here, I'll copy it and paste it in here. One moment, sorry. So if folks want to ask questions or keep the conversation going, you can do so there. Brief introductions, and then we'll get started. I'm Elon. I'm one of the admins of Locally Optimistic. I've been admin for I don't know, 4 years now, and I'm based in Brooklyn, and I work at Brooklyn Data. I'm a VP of Data and Analytics here at Brooklyn Data. Cool. Ray, I'll kick it off to you. Oh, I think you might be muted.
That's true. I was trying to use that space bar, like temporarily unmute. It's not working. But I'm Ray. I'm a machine learning engineer at a company called StockX. I've been in the data space for 11 years. I got my first job as an analyst back in 2011. That's not true. I had an internship in 2009. But anyway, yeah, so a little over a decade.
Cool. Emily?
Hi, I'm Emily Echtel. I'm a machine learning engineer at Vouch, an insurtech company, and I'm based out of Chicago.
Awesome. Travis?
Hey, everybody. I'm Travis. I work at Bowery Farming. We're a vertical farming company that grows leafy greens like lettuce, kale, arugula in the New York City area, or like actually the greater Northeast area. And I've been here for about 4 years, started off in analytics at this company, and then grew into a role on the algorithms team. Before that, I was in a master's program for data science. And before that, I was in another job as a data analyst. Yeah, glad to be here.
Cool. So those will be our speakers today, and I'll help facilitate with some questions and take any questions that people have from the audience as well. Yeah, so as a reminder, we're going to talk about folks' career transition. And I don't even know if transition is the right word, and I think that's going to be the topic of one of our conversations, from analytics to, I'll say, ML. We'll kind of have a good conversation, and then we'll take questions from the audience towards the end. But if you do have questions and you're afraid you're going to forget them, please pop them into the Slack channel. And I will post that again for folks who came in a couple of minutes later. Don't see it. It's right there. So, and for folks speaking, feel free to not answer a question if you don't want. That's totally optional as well. Something that I've always been curious about is just like, before even getting started, kind of analytics and machine learning, in the context of data. There's kind of the big kind of Venn diagram here. I'm curious if folks see this as a like a technical spectrum, and not to say one is, kind of leaving value judgment aside, but just like, if you think, I usually think about it on a technical spectrum, like on a continuum, which is why thinking about like transitioning from one to the other, how do you all think about what does that mean to you? Is it a title change? Is it you're actually doing different work? Is it a different company, a different organizational structure? How do you interpret this kind of transition from analytics to ML? And Emily, if you want to start, that's cool. Oh, you're on mute.
Thank you. I think about analytics, the breakdown that we're describing here is the difference between describing and predicting. And so from my perspective, we're all partners in this. It's whether we're focusing on what currently is or trying to describe what might occur.
Cool. And I guess in your day-to-day, as a professional, how has that manifested differently, let's say in what you're currently working on versus what you were when you would consider yourself as being in analytics?
Yeah, so the difference is that I'm still building my features on top of the, especially at like growth stage companies, I'm still building my features on top of the DIMs and facts that have been created in the data warehouse. All I'm doing is using machine learning models to extrapolate those values out into a potential future or attempt to predict them. So in my experience, 50% of the job is the same. I'd be curious to hear from other panelists though.
Yeah, Travis, you want to jump in?
Yeah. Yeah, so I think like where we're at currently in the like data landscape, there are more technical, like you do need to have more technical skill in order to get into machine learning. Like for instance, if you're in analytics, we have seen this like explosion of tools like DBT that we probably all love, where it's like a lot easier to get involved in like the data engineering portion, the like analytics transformations portion, and be like a really productive analytics person with not as much like software engineering skills, for instance. But in like machine learning now, at least like at my company, it's we do need like a lot more Python experience, a lot more like backend software engineering skills to like be productive. But I think that that's likely to change as like the tools landscape changes and like there's so much activity going on. So it's like hard to say what'll happen in the next like few years.
Ray, you have anything you want to add?
Yeah. So I have a lot of thoughts on this. I'm not going to share them all.
What do you mean? This is your forum.
It will take the whole meeting. But so like I want to start with like something I think is a little controversial, just that for one, like it's not the same from one industry to another. Like big tech is not the same as insurance, is not the same as banking. Just putting like to start out that way. But two, I think the title of analyst is almost seen as like a more junior role by a lot of people and a lot of companies. Not that I necessarily personally agree with that. But if you're using this like as your career path, like if you're just trying to break in, it's a lot easier to break in as an analyst than it is to break in as a data scientist or a machine learning engineer. And if you really want to be on the more engineering side of things, I think it's a lot easier to break in as a software engineer. There's a lot of like well-paved roads for how to do that and then switch over to data or machine learning. But for me personally, like I started as a data analyst. I like mostly worked in Excel for years until I learned that like, hey, if I write some of this in SQL, I don't have to write the functions in Excel. It just will do it for me. So for me, it's like very much like long-term continuous journey towards automation. And then I kind of took it to the most extreme version of that you can go.
That's, yeah, a lot to unpack there, I think, as well, in terms of like kind of breaking in. And I hope that we get a chance to talk about that a little bit more as well. Kind of related to all this, you know, as we're thinking about, as we're talking about kind of the spectrum and how it's maybe kind of, I don't know, marginally different, but then you take the sum of all these little differences and you get like a new role kind of thing, which in ML. How did that transpire for each of you? I mean, you kind of all hinted at it a little bit in terms of what you're doing now and what you used to do, but I'm curious, was there a moment for y'all where you're doing work and then you woke up one day and you said, I'm no longer doing analytics, I am like very squarely doing ML? Or was it a moment of, I'm not doing ML and I want to be doing ML. You know, I'm kind of curious about each of your stories. Emily, if you want to, I don't know if you want to share.
Sure. Yeah. So in one of the ways that I found to break into more of a machine learning role is to be in a small or growth stage type of company, because often their hesitancy to hire an entire FTE to do this work means that you might have an opportunity to, from your current job as an analyst, data engineer, or analytics engineer, be able to like generate proof of concept projects on the predictive analytics side. And that's kind of how I broke into the field as well. And also too, partnering really closely with data scientists and machine learning engineers, building their data sets that they were using to do that work was another way that I was able to understand their needs and concerns, and that helped me transition into the role.
Yeah, I have a like pretty clear story. So like I was working with like a quality control team, and they literally had like a checklist of things that they were looking for these file audits for the Section 8 Housing Choice Voucher Program. It's like a government subsidy program. And they just go through like these files and say, it has this, it doesn't have this is filled out correctly, etc. And then at the end, there's like a big free form text box where they would write all of their findings. And they asked me like, Ray, can you figure out like what is going on with the text forms? Like we're trying to figure out more insights. And I tried to do this in Excel and it was so hard. It was just like impossible to do. So I was Googling and people said I could use Python and NLTK. And I did that. And then I would like kept going and I was like, oh, you can actually like build natural language models. And that was like, for me, like the point in my journey where I was like, oh, this is so much cooler than what I'm doing now. I want to do this more.
Cool. And then, yeah, I think for me, it was like definitely a concerted effort to break into the field. I had done that master's program where I was studying machine learning and like wanted to get a job in machine learning, but was also finding it hard, even with the master's, to like get a full-time role. And I think it was a combination of that. And I was also just really taken with Bowery as a company. Like I thought what they were building was really cool. And I knew that like at the time, there's just like no analytics function. So the way that when I was like starting the job, it was kind of like described to me as like, okay, we need to like build out analytics before we can do like fancy machine learning stuff. But once we have that, then like we're like, my boss was at the time was excited to like move me into that role. But it was definitely like a concerted effort and something where, to echo what Emily was saying, it was really helpful to be at a small company where there was a lot of growth and I could like grow into that role.
Yeah, that's cool.
I was gonna say, I totally agree too. So like I tried to learn on my own for like a year and I made a lot of progress, but I could not convince anyone in interviews to take me seriously. So I also did a master's degree as like a signaling effect type of thing. And that helped. I would get interviews, but they'd still be like, well, you haven't been in the role. Like, I don't know if we can trust you. So I also went to like a growth stage, like Series B startup. So like I have the same type of experience and sentiment as these other folks.
Yeah, I wonder. Oh, sorry. Go ahead, Caitlin.
Can I jump in with a follow-up question on that?
Mhm.
So there's like very clear pros and flexibility to starting at a growth stage company, but how did you find people to learn from? That tends to be what you lack.
Communities like this, especially if you're the only person or one of the very few people in your company performing this role. I got my start in the DBT community, and there is some conversation around machine learning. And I hope in the future there will be more since they're implementing Python models. But that being said, you have to embed yourself in these communities in order to grow if you're the only person in your function. And I think the other thing that to think about is like the machine learning job is also a lot of data ops and DevOps. So just because there's not a machine learning engineer in your company doesn't mean there's not a lot to learn from other folks in those functions.
Yeah, when I joined that startup, I was in the opposite position. So like I wanted to get into data science and machine learning. But the team I joined already had 3 people doing that. So my boss told me, he was like, I don't really want to hire you as a data scientist just because I can find people who are good at those skills, but finding someone who has like the background in analytics, who has experience and is kind of like can be a grown-up around here is really hard. So I'd really like you to do more of that stuff first. And then if you still want to transition later, you can. So I kind of did it the other way around, like got my foot in the door through analytics and then learned from those other people who had the role, which was really good because that team really needed help with like basic stuff more than they needed the advanced stuff, but they had just hired the advanced stuff first.
My story really sounds like Ray's too, where there were some folks doing like machine learning stuff when I joined, but no analytics function. So I was working on that. And then, yeah, it was really helpful to, even though it was a growth stage company, that there were folks that were really experienced that could mentor me in the like ML space.
Yeah, definitely. I think you kind of seeing it and learning from somebody kind of is always going to be, I know in some ways much more valuable than the textbook. And I think that's, you know, if you can find a place that has that, it's a kind of great place to be. In terms of kind of related to that, you know, coming from analytics where, you know, we've seen broken pipelines and dashboards and reports that don't reconcile and kind of this like nuts and bolts stuff that maybe makes the ML, I don't know, maybe second thought, depending on exactly what your business is. But for many businesses, you know, if the reports are broken, almost doesn't matter what the accuracy of the kind of classifier is. Having gone through that kind of boot camp in some sense, and then moving on to ML, how has that changed each of your kind of perceptions on how you do your work? Maybe kind of compared to, you kind of have to put yourself in somebody else's body, compared to somebody who you think maybe didn't experience that, maybe because they, you know, come out of academia into an ML role, or maybe coming from the software engineering kind of world, who has a different set of experiences. Just kind of curious what you think that's like. Anybody who wants to go.
Yeah, so I think like a background in analytics really helped me get more empathy with stakeholders and feel like a more clear understanding of like business needs around like what we might want ML for, just from like working in the like analytics sphere compared to like some folks I know who like didn't go through that beforehand. That was kind of the question, right? Is like what did analytics teach us before we got into ML?
Yeah. Like how has that changed your perspective on the ML you do? I mean, one very cynical take is you start doing ML, you realize that, you know, the kind of foundation that your infrastructure is built on is broken, and that's actually where you should be spending your time. You almost take yourself out of your job in some way to fix like the more important business problem, in a way that somebody who doesn't have that experience maybe doesn't see that. And so I'm kind of, you know, I definitely don't want to bias you one way or the other, but I'm just curious how you've all experienced that.
Yeah, so I agree with Travis. I also think like I'm just much more data first, ML second. Keep things as simple as possible. Do things the non-ML naive way and just call it ML. Like this, like the product managers don't really need to know what I'm doing behind the scenes. I can explain how the algorithm works at a high level. I don't need to go into deep details. But yeah, like focusing on the data pipeline and making sure that I actually understand what that data means and don't jump to conclusions, don't make a lot of assumptions. I've written like some weird posts in the locally optimistic Slack lately about my frustrations working with product managers. But I think like kind of like one of the highlights about it is just really trying to nail down definitions of metrics, since in ML, you are very much like basing your entire model on optimizing against one or a few of those metrics. And if you pick the wrong one, you optimize for the wrong thing. So like, I think like coming from the analytics background and like, you know, defining KPIs and negotiating with the business stakeholders about what those mean and how strict we should be with them has really helped me, you know, kind of stay on target with the models we build.
I think to that, I would add, when you come from a data engineering or analytics engineering background, you tend to focus more on software engineering best practices in your pipeline. And in addition to that, I would say the other thing about coming into the field as a full stack engineer is that I think a lot about that experience of pushing everything as quickly as you can to the point where you can have user acceptance testing. So in my projects, I think about how quickly can I get this to a user interface or experience where the product and stakeholders can interact with it and give me feedback.
Cool. So much good stuff there. Something that kind of stood out to me a little bit, actually, in what Ray was saying around, they don't need to know what happens, you know, just kind of they being the product managers, but, you know, basically like the people outside of the team. I'm curious how you think about how you spend your time and where that is most effective. What I mean by that is, you kind of hand waved away a little bit. The algorithm almost doesn't matter what the algorithm is in some sense, as long as the effect is the kind of the right one, or, you know, it gets us to the same place. Which in some sense says it's true, the algorithm doesn't matter for reasons, but something must matter much more than, let's say, the algorithm that you're choosing. What is the thing that does matter? What is the thing that is kind of non-negotiable in a way that the intricacies are negotiable? Does the question make sense?
I think it makes sense. I mean, for like us at StockX, and then previously at PayPal, it was very much like A/B test results. You know, so you're going to put something out there, you get a user to look at it, and you have predefined definitions for success. So like, if I do the simple one, I do a complex one, I add in more features, the user is going to help me figure out what's working and what's not. In situations where you can't do A/B testing, like you're doing like financial forecasting or maybe like fraud detection, you have you know, bottom line, either like cost or revenue growth type of metrics that you can compare to. You can make it very quantitative, like what success means.
Yeah, and yeah, kind of building off of what Ray was saying is, yeah, I guess where I'm at is that a lot of our services, we like judge if they're successful or not based on whether or not folks use them, like whether or not it's like something like talked about in like business meetings to like help drive decision making, or the service is used for like our actual farm operations. And I think like a place or like somewhere where like I personally want to work on more is like quantifying those metrics, of trying to say like, oh, because of this specific algorithm, it derived this much business value because of X, or like it drove this metric up X%, which I think partially because we're like a young organization and we're still just like building out like the first version of these tools, it's like harder to measure or like maybe a little bit more hand wavy. But yeah, my like goal is to like make that a lot more quantitative and like tangible. Yeah, maybe we can do another panel on that if other folks are experts in that.
I mean, talk about the Holy Grail.
Yeah.
Here's why what I do is valuable to the company. Yeah.
Yeah.
Yeah, you could write. I'd love to join that panel or be an audience member. Yeah. Cool. So thinking about your own journeys, what, and for folks who are going to watch this later and maybe in the audience who are kind of considering this type of a move or have done it and trying to think about their own experiences, if you're willing to share, what is one thing that you would have done differently and why, knowing what you know now?
I'll jump in and say that tool selection, I think in the beginning of this role, I got like overly hung up on trying to make a particular tool work rather than trying to ship and get something in front of my stakeholders as fast as possible. And like upon further reflection, I wish that I had done that differently. So like the landscape for ML tooling is really frothy and there's a lot of exciting and interesting both open source and vendors, but like never losing sight of the end goal, I think is important and easy to do, especially when you're like new in the role.
For me, I think it would be like to just focus on one thing at a time. I tried to like learn 100 things at the same time in a little bit. So I ended up with a lot of breadth and not a lot of depth, where like, I think it would have been better if I just said, I'm gonna just do 2 or 3 months straight on this one topic. And like, if I get stuck or whatever, I'll take a break, but I'll just keep trying to go until I feel like I've actually learned it, rather than I will sample, 100 articles from 100 topics and try and read them every week. It's like it's hard to build on it, when you aren't focused on what you're trying to learn.
I think one thing for me was I didn't focus enough on like software engineering skills to start off with. I feel like I was really put a lot of emphasis in learning algorithms and like really get into the weeds on machine learning models and like how they work, which I was really interested in intellectually. So it was like fun, but not the most useful thing in like the working world now. And like, yeah, as Emily said, the landscape is really frothy. There's a lot of like things you still need to build yourself, or like where it makes sense to like build yourself. And at least for me, I found software engineering skills are like really useful and like needed.
Yeah, that's a really good point, but it's kind of a catch-22, right? Because to get into the job, like you have to do these interviews and they always make you do like, a million algorithms. And so you have to really prove yourself in the algorithms. Then you get there and you're like, I don't know how to make this work though. Like, how do I glue all the pieces together?
Yeah, in the end, data engineering, the ability to connect the pipeline becomes probably the most important, especially if you can pull models off the shelf.
Yeah, I once had a interview with a company that I thought was going really well. Like they were saying like the biggest challenges they had was they had really smart data scientists and really sophisticated models. They had a really hard time getting them to be production ready and to get them in front of users. And I went over like how I've done this over and over and like been able to help them. And then I got feedback the next day that they wanted to pass because they were looking for someone who would help level up their math skills rather than their software skills. It's like, you guys are so like, you're missing the point here. But I'm just saying, like, I think the field in general, like we focus sometimes on the math and the algorithms more than we should.
Yeah, I have a similar experience in which I have yet to have to implement the balancing parentheses algorithm that they sometimes ask you in one of these interviews, which really threw me for a loop because I don't think there's any machine learning needed to do such a thing. It's like a recursive thing. And yeah, I also don't know why they do that, other than creating artificial barriers. But that does lead me to my next question, which is kind of similar to the theme that I heard from the last time. In terms of resources, right? So we talked about kind of it's frothy, you're not pushed into, but maybe nudged into more of an academic kind of in the weeds education versus a practical software engineering education. that you wish would be different, and so on and so forth. What, like, in terms of resources, books or otherwise courses, what would you say is the best, the one that sticks out in your mind as the most helpful that you would recommend other folks who are thinking of following a similar path?
I'll hop in here because I had a really good experience with Co-Rise. So Co-Rise is these really focused courses where you level up on a particular skill and you get instructors who've been in the field for usually 10 or 15 years, and often like a Stanford quality of like lecture, but with practical projects and things that you can then, I would often find myself learning something over the weekend and then porting it immediately to work on Monday. So there is a machine learning foundations track and some other interesting courses that they offer, data engineering and analytics engineering. So definitely check that out. I found it to be really helpful in improving my job performance.
I don't know if this is like the one book you need to read, but one that I have liked is Designing Data Intensive Applications. It's just like a really good overview of, yeah, fundamentals of like how to design these like services and systems. And yeah, it's a gold mine.
That's fascinating. They say that, so I'm looking at it. I have it over here and like making my way through it. I haven't, I don't recall seeing much around kind of, in quotes, classic machine learning there. And when I say classic, I mean the kind that you probably studied, which is like, what is naive Bayes algorithm and so on and so forth. But it's certainly, to your point, around services and how they connect and how to think about kind of the broader systems. So just like really interesting that is a resource that you found kind of head and shoulders above other ones. And I would venture to guess that people aren't opening that as their first, or kind of like when they think about how do I get into machine learning, I'd be shocked if they open up that book, but I think that's a really salient, really interesting point. Yeah.
Yeah, no, I totally agree. It's definitely not like the first one that you'd think of like for machine learning things, but it's definitely been, yeah, like a little bit more like fundamental maybe. There's a few other O'Reilly books that are quite good around machine learning. Chip Huyn just wrote one on, I forget the title, I'll find it and drop it in the chat, but I thought that was really good. There's another from some folks at Google that was like, most common things that people run into when designing machine learning applications. I'll find both of these and put them in the chat. I thought those were really good. All of the titles are like very similar. It's like something machine learning, and so.
Well,
yeah,
that's part of the challenge, I think, right? Is that they all kind of sound the same. The table of contents are 80% the same, more or less. So it's kind of like, how can you help those other folks say, okay, of the dozen books that are interchangeable, here's the one. Ray, I'm curious, one of your many takes.
I was going to say designing data intensive applications too. That was what I was going to say. I've read it twice. I want to read it again because I feel like every time I go through it, I like pick up some nuance. It's kind of complicated. It's not like so technically in depth that you're going to be way over your head. As long as you have some computer science like fundamentals, taking like a 101, you can probably get through this book. But the more you learn and the more you do, I think the more the problems start to be relatable and you start to have your own intuitions about how things work. So I feel like it's kind of one of those books that makes more sense on the second or third time reading, which is why I want to get at it again. It's been a few years. I don't know if I've read a lot of books, probably like 70 books. I don't know if I have like another one that I really highly recommend. They all have pieces that are good and they all have parts that are kind of annoying. What was I going to say? I have a love-hate relationship with Fast AI. Like Fast AI has taught a lot of people how to be like, do machine learning and do deep learning. But yet like a lot of them that I work with, they like only know how to do deep learning and like they only know how to frame problems in that like I don't need to do a lot of feature engineering. I only need to like throw the data in my model and like make my model more complex. And then they want to use like the fast AI Python package, which makes some things so much easier, but then has got a million dependencies and makes deploying it kind of harder unless you actually just export it and run it in like Torch serve or something else. Like anyway, I don't know. It's all complicated. I don't like want to get too deep into that, but like it's one of those things where the coursework and like the learning is really good, but then if you don't have other fundamentals to go with it, like you just kind of get stuck in this narrow way of approaching problems. I think data science in general is all about being flexible and being willing to like think outside the box as long as you're using data to solve the problem. Yeah.
Cool. Awesome.
I was going to say real quick, I forgot, for me, like the most helpful stuff though is just trying to do projects. So like whether it's through work, trying to do it on your own, just like getting your hands dirty and trying to solve something is like what works for me the best. So I said I read a lot, but like reading just doesn't do you any justice unless you have something tangible and concrete to go back to and say, oh, that's why they were saying that. Now I know. I tried to do it and I messed that up.
Yeah, I think kind of I totally echo that. Hands-on is always kind of the best way. It's you kind of feel the pain in some way that you know abstractly just can't. I have a couple other questions, but I do want to give folks who are listening a chance to ask questions if they have any. It's kind of opening the floor. Please feel free to unmute, and if you're comfortable, turn on your video, but not necessary. Hey
everyone, so a quick question.
there.
Get to speaking about software engineering skills a little bit. So my background is mostly kind of in data engineering, and I did get a master's in data science. We briefly went over some software engineering skills, not a ton though. It was more sort of like algorithm based. Is probably mostly what I got out of the entire program. So my question is just like, what are some software engineering skills you guys find useful or are using sort of in your day-to-day work?
Yeah, I think like so let's see. So I think like having a good understanding of the offerings from different cloud providers has been really helpful, and like developing that of like, oh, this is when we should use S3 to store things, or like this would be good for a Redis database, or like these like tools around the algorithm have been like really helpful for productionizing these services. I think I've gotten a little lucky in that there are folks at my organization that do have a lot of this experience that I worked on these projects with. And I think that that was really when I learned all of this stuff, is by pairing with those folks and having them do code review on things that I've written, or just like review design documents before we start projects. But yeah, developing a good understanding of like cloud offerings has been really helpful.
Yeah, that's one area I definitely wish we touched on a little bit. Where I'm at right now, we use GCP, but not really a ton. We're kind of just sticking to our internal database, which is not great because I don't know why we're paying for GCP then. But at least it's there as an option to use, which is good. Yeah.
Cool.
So,
Emily, go ahead.
oh, I was going to say one of the things that determines whether or not a project will be successful is how quickly you can move through data and machine learning modeling iterations and go back and forth between them. So there are some really obvious things that software engineering has been doing for at least 20 years that if you bring into your machine learning projects, improves. So we do a lot of the same things, but then perhaps we extend them. So we like do a lot of testing both of the code and the data, but then there's some specific kinds of testing we do for machine learning models on top of that. And that really improves your ability to iterate rapidly. And then of course, CI. So some of these things aren't terribly original. They just have extended applications in machine learning.
Yeah, the dev feedback loop while building models is super critical. If it takes you like 3 days to understand if your model works, like you're just going to end up, submitting like 100 different training jobs at the same time, because might as well, like you're not going to hear back from them in days. But if you have a way to like get a feedback loop in under an hour, you can make a lot of progress incrementally. Typically, that means you're working on smaller data sets. And then you learn from that. And as you learn, you get better ideas and you figure things out, you expand that up and scale up. I posted a link called 12-factor app. But it's just like a 12-factor app is like pretty common thing in software for how to design applications. It basically just means like split your app up into different pieces. Don't try and do it all as like one giant thing. But it gives you names for things as well. So like Emily talked about CI. So like that's like the build and release part of it. Like, so, as you're making changes, you're running automated tests. As those tests are passing, then you can do automated deploys. You're not really worried about this like continuous development, right? Like you're not really worried about cutting specific versions and having to do like complicated rollouts. You just can make small changes incrementally and they will automatically ship as long as your test pass. That stuff really helps too. Logging and monitoring of your applications is super critical. So like at StockX, I'm like kind of in charge of recommendations. And so we have machine learning metrics that we use. So we use like mean average recall, and we use the mean reciprocal rank and like the NDCG. It's like normalized discounted cumulative gain. It's just a way to say like, are the things that we're recommending getting clicked on? What does the order that we present them in matter? Are we presenting the best things first? That's like the machine learning type of metrics we're looking at. We also look at business metrics, like are people like ordering the things we recommend, or are they just clicking on them? Because I want to optimize for stuff that ends up improving the bottom line, not just the click-through rate. And then 2 is like the stuff I'm trying to get us to get into that we're not doing because it's too hard, is like user retention. We want people who engage with our recommendations to feel like they're discovering our product catalog more and feel like they're engaging with our app more. And so like, ideally, we should be able to say like the people who are getting our newer models are feeling better connected to what we have on our marketplace and better or more interested in coming back and seeing what else they can find. So what I'm getting at here is like, kind of goes back to analytics, right? Like this is stuff that you can build a dashboard around, and those dashboards should help you inform what ML is working and what techniques you should do to improve your ML. Because like a big problem I've seen over and over again with data scientists who don't come from an analytics background is they build the models and they only use accuracy, or they only use recall, or they only use F1 score. And then they like don't really understand that those don't matter if the business objectives aren't moving as well. So like if you have a fraud detection model and you're using recall as your performance metric, but then you're losing money because you're canceling too many orders, like your model is losing even if you think it's doing better. So like that's kind of like part of the software side that I think a lot of that like analytics can help machine learning people learn from.
Super helpful. I think we have time for one more question from the audience, if anybody has any. No worries if not. I guess I would love to end with, we kind of talked a little bit about, everybody's journey and their thoughts about how analytics has helped them, learnings, things that they wish they would have done differently. I would love to leave everybody here and everybody listening with kind of a piece of advice from the battle scarred. What is one thing that you would recommend to folks on this path, or looking to do this path do?
So my advice would be to assume you're ready earlier than you think you are. Just put yourself out there and try an interview. And like, so I've told a bunch of people this, it's kind of weird, but you only have to trick one person, right? Like if you trick one company to think you're good enough, then you are by definition good enough. You get that title, you get that job, then you're in the door, right? So I just like talked with a lot of people who are like, what do I need to study to get ready? It's like, why do you assume you're not ready? Like I've met people who have like, 10 years in the field and a PhD who aren't ready because they don't they look at the wrong stuff and they care about the wrong stuff. So I think as long as you're thinking about things in the right way, like the skills they'll come along with the job. So maybe practice interviewing is more important than practicing the software and the ML.
That I'll just jump in, speaks to me on so many levels, so deeply, because the advice that I got when I was kind of getting to data science was fake it till you make it, which I think could basically be applied to so many spheres of life, but like in this one, I absolutely think it was true. And let's say still continues to be. So yeah, love that.
My advice is to be an active participant in your communities, both giving and taking. So I really do view communities like Locally Optimistic and other communities I'm a part of as my colleagues. I ask questions, I try to help where I can. And also, depending on your stack, you may be using a lot of these open source projects that other people have contributed to. I really enjoy being a part of the hive mind and value the community and feel like I am smarter because I am plugged in. So that's my advice, is to be an active participant.
And then my advice would be to find folks who you look up to, whose skills you'd like to develop yourself, and then just become friends with them and try to work on projects with them and try to get them to review your code. So I think that's been the best way that I've learned.
Awesome. Those all sound very very actionable, which is really helpful, and I would say like accessible. It's not like go off into the world and do this thing that's crazy. It's kind of be scrappy, find some people, there are networks out there, and kind of, it's almost like don't take yourself so seriously. So yeah, love all of that. And I think we'll call it there. There's probably a lot more to talk about, and maybe there'll be a part 2. But I really want to thank everybody for your time, for the audience and the speakers, and Caitlin for taking great notes. Everybody can hop into the Meetup Analytics to ML channel to continue that. And yeah, I hope everybody has a great rest of your day. Thank you again, and looking forward to seeing all of you on the Slack channel. Bye, everyone.
Thanks.
Thank you, everybody.
Bye.
Thank you.